Okay, started the recording. Okay, so so are we clear about the cross multiplication by this method?
Yes.
Yes, sir.
Yes.
This will be very effective. If you practice a little bit, you will get it, very fast.
Yes, sir.
Okay.
Okay.
Okay. Next, we move to power of numbers. Okay. Now, power of numbers
Power
means
of numbers.
the simplest power is to the power 2, right? So let's see what behavior we have if we consider powers of 2. So 1 to the power 2 is 1, 2 to the power 2 is 4,
4.
3 to the power 2 is 9, 4 to the power 2 is
16.
16.
16, 5 to the power 2 is
25.
25.
25, 6 to the power 2 is
36.
36.
7 to the power 2 is
49.
49.
8 to the power 2 is
64.
64.
9 to the power 2 is
81.
81.
okay. Tell me what you notice from these powers. Things to note. Number 1, do you notice anything in these numbers? Any pattern that you notice?
Mini
There is a
pattern.
difference. One
Odd numbers.
that 5, then again 6, 9,
Addition of
4, 1.
odd numbers. Like 1
Addition.
plus 3 is 4 and 4 plus 5 is 9. Then 9 plus 7 is 16.
9 plus 7
No,
is 16. Yes.
there is a
No.
definitive pattern. Look at this number, last digit 1496.
Yes.
1496.
Divider is 5.
Told you, sir.
5, right?
Yeah.
Yes.
So what can I say about this? So if my last digit of a square is 1, then the last digit of the original number is what?
1 or 9.
1 or
1 on 9.
9.
Yes.
If my last digit is 4 of the square, the last digit of my original number is
2 or 8.
2 or
2
8.
or 8. If my last digit is 9, my original number is
3 or 7.
3 or 7. If my last digit is 6, original number is
4 or 6. 4 or
4 or
6.
6.
4 or 6. And of course 5 means original number is 5. And of course we know if the last digit is 0, then the original number will end in a 0. Right? Right? Am I right?
Yes.
Yes, sir.
Sure. Are you sure? I'm talking about 0.
If the last digit is 2 has 2 zeros, then there must be 1 0 in the original number.
Yes. If the last digit of the square is 0, we cannot say anything about it. The last two digits has to be 0. Then only the last digit of the original number will be 0. Okay, like 50, last digit is 0, but square root of 50 is not ending with a 0. But 100, 200, right? All these numbers will have the last digit of the original number as 0. Clear?
Yes.
Okay. Now, what else do you notice from this? What else do you understand from this pattern?
Sir, I have a hello, sir. Hello.
Yeah, tell me.
Sir,
Anything?
am I audible?
Huh?
Okay. I have a question.
Tell me.
Yeah. Does the square root of 500 contain 0 in the
No,
last
no.
one?
So
There is also
correct.
two
So
zeros in the last.
this is root 5 into 10, right? If I take the square root, right? So all I'm saying is that if the last number is only 0, then we cannot say anything about it. And you are right. Okay. So this is not exactly a whole number. Okay. So 0 has to be considered in a different way. Okay. All perfect squares like 100, 400, 900 or
I guess
1600.
this
Okay.
cannot be defined as the traditional method.
Yes. So only if they're perfect squares, then they have to have 2 zeros.
Yes.
That's the point. Okay. Okay. What else do you notice from this? Anything else do you notice? Okay, let me give you a hint. What are the missing numbers here? What numbers are missing here?
2, 3,
2,
2, 3,
3,
and
7,
8.
8.
3, 5, 5,
7,
Oh,
8.
so 7, 8.
7, 8,
7,
2, 3, 7, 8.
7, 8.
What does this mean?
Yes.
That any number ending
If
from
they.
these digits is not a perfect square.
Absolutely right. Any number that ends in 2, 3, 7, 8 is not a perfect square. Not a perfect square. Right? These are things you have to apply when we get into the problems. Okay? Any number ending in any of these 2, 3, 7, 8 is not a perfect square. That is number one. Number two, what pattern do you notice here? Look at the pairs 1, 9, 2, 8, 3, 7,
Adding
4,
up
6.
both is 10. Addition of both is 10.
All these add up to 10,
Make 10.
Yeah.
right?
Yes.
All these add up to 10, correct? Now, how do we remember this? Without doing all this, what is the simplest way to remember this? The simplest way is, now we know that the pair of numbers will add up to 10, right? So what are the pairs? 1, 9, 2, 8, 3, 7, 4, 6, and 5, 5, 5 and 5 is same, so you don't have to bother. So automatically you get the pattern, you get the You get the
Other number.
yes, the couplets, right? 19283746, right?
Yes.
And
And
the
remember this
1 3
pattern 1496.
Okay.
That's it. I'll repeat again. So start off with 1, 2, 3, 4, 5. Okay. So 10 minus 1 is 9. This is 8. This is 7. This is 6. And this will be 5. And I know the pattern is 1496. 1496. So that means if my last digit of the squares are any of these, then these will be the corresponding possible values of the original number. Last digit of the original number. Make sense?
Yes.
Yes, sir.
Clear on this? Any doubts?
No. No, sir.
Okay. This is again a very, very important thing to understand and apply. There will be numerous places where you'll have to apply this concept. Okay. Now let us look at a few examples. Okay. Tell me what would be okay. Um, okay, let me do one thing more, then I'll get into the problems. So we've done the squares, right? So these are
Yes.
power of 2. So if I do power of 3, what would be the last digits? 1 is 1, 2 would be,
8. 8.
3 would be,
27.
7. I'm considering only the last digit, okay?
Okay.
4 would be,
6.
4,
4.
what is
Sorry.
4 cube?
64.
4,
4.
5 would be,
5.
5, 5,
6 would be,
6.
6,
6
7 would be,
3,
3
3.
8 would be,
8,
2
2,
2.
and 9 would be.
9.
9.
What do you notice here?
All the numbers are present.
Hmm?
All the numbers present 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 to 9.
No, no. What
It's
is the
the
pattern that you notice?
pattern. Mm,
See, these patterns are what matters, right? Because when you get into applications, you will not get time to do all this. You will have to remember the patterns. That is most important. So
For
what
the
pattern do
first
you
three
see here?
numbers, it is adding up to 10. 8. Sorry. 8 and 2, 10. 7 and 3.
9 and 1 is 10, right?
8 and 2 is 10.
Yes.
Okay.
8
8 and 2 is 10, right?
7
7
and
and
3
3
is
is 10. 4 and 6 is 10. And of course 5 will be left.
5.
So if my last digit of a cube is 1, then what is the last digit of the original number?
1.
If the last digit of the cube is 1, what is the last digit of the original number?
1
1.
1.
1.
If the last digit is 2, what is the last digit of the original number?
8.
8
Last digit is 3, original number.
7.
7.
Last digit is 4, original number.
4. 4.
Last digit is 5, original number
5.
5.
5.
Last digit is 6, original number
6.
is 6. Last digit is 7, original number is.
3.
last digit is 8. Original number is?
2,
And last digit is 9. Original number is?
9, 9, 9.
Okay.
And
So what do you notice here?
The addings of this
1 gives 1,
yes,
right?
2 gives 2,
yeah,
4 gives 4.
and 9 gives
5
9.
gives 5, 6 gives 6,
5,
and
6
9
can be
gives 9,
constant.
right? So what are we left with? 2, 3, 7, 8. Remember, these are the 4 numbers which do not
No
end in a square.
all
square. Yes,
Remember,
yes,
sir.
2,
Yes.
3, 7, 8 cannot be the last digit of any perfect square, correct?
Correct.
And in cube, they form patterns, they form couplets. 2 gives 8 and 8 gives 2. 3 gives 7 and 7 gives 3. See the pattern?
yes, sir.
Understood? Understood?
Yes.
Okay. So therefore, in case of cube, if I summarize, then I can say that all numbers except 2, 3, 7 and 8, they end up in their own numbers. 0, 0 to 0, 1 to 1, 4 to 4, 5 to 5, 6 to 6, 9 to 9. And this would be couplets with total of 10. So 2 to 8, 3 to 7, 7 to 3, 8 to 2. 2, 3, 7, 8, 2, 3, 7, 8.
2, 3, 7.
Make sense?
Yes.
Yes, sir.
Tell me, any confusion, any difficulty you're facing on this? Because this is the fundamental, this is the basic that you need to understand and not memorize, but understand the logic. So you have to basically remember two things. So one is 1496. If you remember this, you'll remember all squares. And 2378. If you remember this, you'll remember all cubes. And
Yes.
2378 also you can remember because that will not give a square.
Perfect square.
Clear?
Yes.
Yes, sir.
Yes.
Yes.
Aklesha, clear?
Yes, sir.
Bhavishya,
Yes, sir. Clear.
understood? No problems till now?
No.
Okay.
No.
Next we go to the fourth power. So let's see what happens here. So 1 is 1. 2 would be what?
6.
Power. Yes.
3 would be?
1.
1,
4 would be?
6.
6,
5 would be? 5.
5.
6 would be
6
6.
will be 6.
7 would be?
1.
1,
8 would be?
6.
6,
And 9 would be?
1,
1.
What happens here?
1, 6, 1, 6, 5, 6, 1, 6, 1.
What is the pattern here?
1616.
1, 6, 1, 6, 5,
1616.
1.
1616. 1616.
1.
And 5.
Right? So the last digit of a cube cannot be what? What are the missing numbers?
2, 3, 4.
Sorry, not cube. Power 4, not cube.
Power 4. 2, 3, 4, 7, 8.
2, 3, 4, 7 and 8.
9 also.
9 also.
9, sorry. 2, 3, 4, 7, 8, 9. So none of these can end up as the last digit of a fourth power. Clear?
Yes.
Yes.
See, there is
Yes.
another interesting pattern. So if you look at this chain, so 1 1, and if you look at from the bottom 1 1 alternate, and
Yes.
if you look at 6, the pattern is 6 6, and then 6 6, and then 6
And then
6.
Six,
So
six.
2 4 6 8 will all end up in 6 in the fourth power, right?
yes.
Right.
And
Yes.
1 3 7 and 9 will end up in 1. 1 9 7 3 end up in 1. 2 8 4 6 end up
End
in
up in
6.
Six.
Interesting, right?
Yes.
Yes.
Getting it?
Yes,
Yes,
sir.
sir.
Okay. Now, let us go to the fifth power. What happens here? 1 remains 1. 2 becomes
Two,
2. 3 becomes
Three,
three,
4 becomes
four,
4,
5 is 5. 6 is
six is six, 7
7
is
becomes
7,
8 becomes
8,
8,
9 becomes
9 becomes
9.
9.
so what does this tell you?
That the last digit remains the same in case of 5 power.
It remains the same. Okay. What does that mean? Are you getting any pattern now? In power of numbers, you have to understand the patterns. Okay,
Okay.
that is the most important aspect of this. So we can understand that in the fifth power, all the numbers will have the same last digit as the number itself. 1 to 1, 2 to 2, 3 to 3, and so on. Right?
Yes.
What happens to the sixth power? 1 is 1, 2 becomes,
4.
3
It
becomes,
will give the same power as 2.
let's see, 4 becomes 6, 5 is 5, 6 is 6, 7 is 9, 8 is 4, and 9 is 1. Right? Yes. So now tell me, what is the pattern that you are observing in terms of the
in
powers?
1496 6 6
What is the
4
pattern?
in all the hours.
1, 5, 2, 6, 3, 7.
The number is
1
repeating itself
always gives
after
1,
every second.
5 always gives 5, 6 always gives 6.
Yes,
Okay.
yes, yes.
Now, apart from that, what is happening?
In case of 9, it's always repeating 9191 type.
So, if I look at 2, it gives the pattern 2, 4, 8, 6.
6.
Right? 2, 4, 8, 6. And again 2, 4, 8, 6. Right?
Right.
Yes,
3 gives the pattern 3,
3, 9,
9,
7.
7, 1.
7,
3, 9, 7, 1. 4 gives the pattern
4 6
what?
4 6. 4 or 6.
4, 6, 4, 6, 4 and 6.
6 4 4 4 and 6.
4 and 6. 5 and 6 is okay. 7 gives the pattern 7, 9, 3, 1.
7, 3.
9 3 1.
Right? 8 gives the pattern
Yes, 8 4 2 6.
8, 4, 6.
and 9 gives the pattern.
9, 8.
What do you notice here? Look at 2. The powers are giving 2, 4, 8, 6. Now look at this. 2, 8, 4, 6. Adds up to 10. Right? So
Yes.
how will you remember? Okay, so see, 2 gives 2 in the first place. So 8 would be the third one. Therefore 4 would be second, 6 would be last. 3 gives 3 as the first one. So 7 would be the third one, because 3 plus 7 is 10. 9 plus 1 is 10. So the next would be 9 and last one would be 1. 4 will only give 4 and 6. First is 4 and then 6 and then it repeats like that. 7 gives us 7, so the third number would be 3 and then 9 and 1. 8 gives first as 8, so the third would be 2, 4 and 6. And 9 is 1 and 9. Yeah.
Yes, sir. Yes.
Very, very interesting patterns, right? Any confusion on this? Any confusion?
No, sir.
Yes, no?
No, no.
No, sir.
Okay, so 2, 3, 7 and 8. Remember 2, 3, 7, 8
Yes.
cannot end.
Not perfect square.
Perfect squares cannot have the last digits. So here also 2, 3, 7, 8 are the only 4 numbers which gives a repeating pattern of 4. Right?
Yes.
4 and 9 gives a repeating pattern of 2.
Two numbers.
Right?
Right.
Yes.
I wrote this wrong. This would be 9
Yes,
1.
it should be 9
First
1.
power is 9.
9 and 1.
Second power
Nine
is
and
1.
one.
Yes, I
Okay.
have a link. And
So 2, 3, 7, 8 are the 4 numbers which repeats every fourth power. And 4 and 6 are the 2 numbers which repeats every second power. Rest of the numbers 0, 1, 5, these
6.
left out
6.
anything? 6, yeah. 0, 1, 5,
4
6. They always end in the same number in all powers. Clear?
Yes.
yes, sir.
I'll take a pause here. Just look at it and tell me if you have understood the pattern. Understood?
Yes, sir.
Is it clear?
Yes, sir.
Okay, great. One last thing to note is 2 and 8 as well as 4. They have even numbers, all even numbers. Obviously, even number to the power of even would be, to the power of anything would be even.
Even.
So 2486 and 8426, the numbers are the same, but the order is different. For 3 and 7, it is 3971 and 7931. Right?
Yes.
Yes.
So these two are again having the same pattern. Clear?
Clear.
Okay. Now let us get into some interesting stuff. So tell me, what would be the last digit of 2 to the power 99.
2 to the power 99, 90. Okay.
2 to the power 9.
8.
Is this correct?
Yes, sir.
How did you say 8, Aklesha?
There's a trick, sir, that 2 has 4 repetitive number of digits
Right.
at the end, so we divide 99 by 4, and
Correct.
whatever the remainder is, we take that digit.
Absolutely correct. The others got it?
Yes, yes, sir.
So whatever is the power, right? You just divide that power by 4 and take the remainder. So in this case, 99 by 4 is 24 is the quotient and 3 is the remainder.
Yes.
So whatever is the last digit of 2 to the power 3 will be the last digit of 2 to the power 99, which is 8. Clear?
Yes, sir.
Is it clear to everyone?
Yes, sir.
Yes, sir.
So what did I do? I just took the power and I divided it by 4 and I took the remainder, and whatever is the power, whatever is the value of the last digit of that number, which is 2 raised to the power of the remainder, which is 3, would be the same as the power number given. Clear?
Yes, sir.
Okay. Now we are actually getting into cat level. Okay. So tell me what would be the last digit of 133 to the power 132.
3.
3. Anyone else with any other answer? Anyone else with any other answer? Okay. How do we do this? We ignore the other digits. We just look at the last digit and we look at the power. Now, what is the pattern for 3? 3 to the power 1 is 3. 3 to the power 2 is 9. 3 to the power 3 is 7. 3 to the power 4 is 1. Right?
Yes.
Correct?
Right.
3, 9, 7, 1. Right? What is 3 to the power 0?
1.
1.
So I will go with the same logic. I divide 132 by 4, which gives me what?
0 remainder. 0 as the remainder.
33 is the quotient and 0 is the remainder. So I raise 3 to the power 0, which is my remainder. I get 1. Right? Am I right?
Yes.
No, I am not.
But it should be into 3.
This is wrong. So whenever you have a 0, take the fourth power. That is the
Okay.
rule. 3 to the power 4 is 81. Right?
Yes. Okay. Right.
3
Right.
to the
Right.
power 8 would be 81 into 81. So 1 into 1. Right? 3 to the
Right.
power 12 would be 81 into 81 into 81. 1 into 1 into 1. Clear?
Yes, sir.
Whenever you get the remainder as 0, take the fourth power of the number. Is it clear?
Yes, sir.
Yes, sir.
Okay. Rahul, Shobik, clear?
Yes, sir.
Okay.
Yes, sir.
So let us take another example. Let's say 37 to the power 67. Last digit.
Three.
3.
Three. It should be
Sorry, come again.
three.
3.
Three.
Everyone got this?
Yes.
Yes,
So
sir.
we divide 67 by 4.
4.
We get a remainder of 3. So 7 to the power 3 gives a last digit of
Is
3.
last digit of
Three.
3.
Right?
Yeah.
Okay. Tell me what would be the last digit of 79 to the power 173 plus 82 to the power 69. What would be the last digit of this?
One.
Sorry?
One.
1.
One.
Yes.
Anyone else?
One, sir.
Everyone got
1.
one?
Yes.
Yes, correct.
Aklesha, you got one?
Yes. Yes, sir.
9 plus 2.
Okay.
Yes, 9 plus 2.
Yeah, very simple. Divide 173 by 4. You
Hmm.
get 1 as the remainder. So 9 to the power 1 is 9. And 69 by 4, you get 3. You get 1 as a remainder. So 2 to the power 1 is 2. So 1.
9 plus 2.
So 173, we have to divide it by 2. 9,
Yeah,
the
9
repeater
is
of 9 and 1.
9 is 2. So you divide by 2. So anyway, you get the same remainder.
Yes.
Correct. Okay.
Yes.
Okay. Let us take one more example. Uh, 59 to the power 183 minus 37 to the power 782.
Zero.
Zero.
0.
0, right?
Yes.
Everyone got this?
Yes.
Yes, sir.
Yes.
Okay. Next one. 33 to the power 137 minus 22 to the power 63.
One minus 3. 2. 2. 2 I guess. 1 minus 3, 1, this 11, so 8, 8, 8.
What is the answer? 8 or 2?
8.
8.
What are the others saying? So this is 3 to the power 1, right? 137. If I divide by 4, remainder is 1. So 3
Remainder
to the
is
power
1.
1 is 3. And
5.
this
3
remainder would
minus
be
1.
3. So 2 to the power 3 is
8.
8,
5.
right?
Oh, 5, sorry. Minus
5.
5, 5, 5. 5, yes.
3 minus 8 is minus 5.
Minus
No,
5.
13 minus 8. 13 minus 8.
Yes. You can do 13
It
minus
is
8,
the same
or you do minus 5 and add 10.
from 10.
Yes.
Yes.
Here.
Yes, sir.
Yes, sir.
It is one and the same thing. What you told is correct. So 13 minus 8 means I'm adding 10. Correct. So it would be 5. Okay.
Yes.
Is it clear?
Yes, sir.
Yes. Sir.
Hmm?
Yes, sir.
Yes, sir.
Okay. Now we will do one last thing and then we'll wrap up for the day. So tell me how many zeros. Okay, no, forget it. Tell me what is the highest power of 5 in factorial 20. Highest power of 5 in factorial 20.
4.
4.
4.
4.
4. Correct. So we have 5, 10, 15 and 20. These are the only 4
20.
numbers in factorial 20 which has 5. So I get 1 5 here, 1 5 here, 1 5 here, 1 5 here. Right? What is the highest power of 2 in factorial 20?
Eighteen.
5 plus
10.
Huh?
18, 18.
18. 18.
18.
Sorry.
18.
18.
18. Yeah.
1 8, 18.
18.
Yeah.
How did you get 18?
It has a trick using box function. 20 by 2, 2 plus box of 20 by 2 plus box of 20 by 2 square plus and so on.
Right?
Yes.
This is what we do, right?
Yes.
So there is a simple way of doing this. So you divide 20 by 2, you get 10. You divide it by 2 again, you get
Yes.
5.
Yes.
Divide by 2 again,
Two.
I get 2 and then 1.
You get 1. So you add up these things: 10, 5, 2 and 1. Okay. This is
Yes.
easier to do than doing this. That's the only thing. When you deal with bigger numbers, you just go on dividing it and just add except the first number, add the rest. That's it. Okay.
Okay.
Yes.
Okay. Any doubts on whatever we covered today? Anything that you didn't understand or you have some difficulty? Is this making sense? Is this helping?
Yes, it is helping, and we have to do some homework. If
Yes,
we
obviously. I will start assigning tasks from today, right? So I will send you the link. Rahul and Sovik, you are acquainted with QuizStar, so
yes,
just help them out. So there's nothing, Aklesha, I'll just send you a link. You just click on that link, okay? You will.
Okay.
I'll send you the user ID and password. So you just input that. When you enter that site, you'll see a question paper in front of you. Just take that paper. That's it.
Okay.
Okay, it's an online portal where we do online exams, and I prefer that because it gives you a flavor of the actual CAT paper or actual, management exam papers.
yes.
They're all online. Okay,
Okay.
Okay, sir.
so that's it for today. So we wind up here, and I'm going to send you the recording, and I'll send you the exercise by today.
Next
Yeah.
class.
You'll be sending that on WhatsApp?
No. I'm going to
No,
send it on. Okay, I can send it on
Email.
WhatsApp. I'll send it both on WhatsApp as well as on Skype, so that you
Okay.
can check it in either place.
Next
Right?
class.
Next class would be tomorrow.
Tomorrow. Okay.
Okay. Bhavisha, just tell me your timing. Is this timing fine for tomorrow?
Yes, sir. It's fine for this week. It's fine.
For
I'll
this week?
have to check. Yes, I'll have to check for the next week.
Yeah, just check for the next week and let me know at least one day in advance so that I can tell the rest of the people. I'm
Yeah,
fine with
sure.
any time, but we'll just have to coordinate with the others.
Okay,
Right?
sure. I will. Okay.
Okay, guys. Thanks a lot. Have a nice evening and stay safe. We meet again tomorrow.
Okay. Okay, sir.
Thank you,
Thank
sir.
you. Good
Thank
night.
you. Bye.
Thank you, sir. Good night.